Hello, my name is Carlos da Silva. I'm in charge of mobility product at Cloud Connect. Been working with the team of Stefano, Mauro, Ilvia, and Sam to bring this innovation to you. So without no further ado, let me jump right into it. So as any innovation, it's important to look at the market that we are trying to address. And the market we're addressing with this innovation is the data connectivity and mobile data connectivity and roaming industry. And we're looking at it with the three time horizons, Horizon 1, 2, and 3. For the last 30 years, roaming and data connectivity has seen quite huge innovations in 2G, 3G, 4G, and 5G. But it's been a very competitive industry price-wise, with a lot of price pressure at the retail level. In the recent months, we've seen a very promising new product called travel SIMs, which is generating a lot of new revenue and a lot of new potential in this industry. But travel SIMs are offering an innovation which is a price arbitrage. So it's cheaper than the regular retail price. And in regions like Western Europe, for instance, where roaming is not an incremental cost to the retail users, travel SIMs are not really needed there. And what I'm saying is that this innovation, travel SIMs, has a limited window over time as the price difference decreases. Why is this important? It is important because MNOs need to monetize their investments in the long term, especially the 5G huge investments they made lately. So MNOs are looking at innovations that will enable them to monetize this. And when they look at 5G, they know that the main solution to monetize their investments doesn't come from retail subscribers. It comes from enterprises and IT use cases needs of these enterprises. It is important in our business to know your customer, but know your customer's customers. And here we're talking about enterprises. So the next two slides, I'm just going to talk about this market, the enterprise market. What is happening there? In the enterprise market, IT teams have been moving to the cloud at full speed in the last 10 years. And although they might have started moving to the cloud as a cost replacement of an on-premise solution, this is not any longer why they move to the cloud. Enterprises are moving to the cloud because it's a necessity. It's a necessity to keep relevant in whatever business that they do. It's a necessity to develop new products composable with other solutions, because these solutions are only available in the cloud. If they want to do AI is available in the cloud. Even if they do some on-premise, there is some functionalities that will have to be consumed or used or developed in the cloud. So for enterprises, it is now a business necessity to go to the cloud. The other business necessity is to automate these solutions because of the lack of skill sets and resources available to do everything manually. So telcos need to understand that their enterprise customers that will use their 5G networks are all moving to the cloud and need telcos to facilitate this move to the cloud. So what exactly is these enterprises expecting for? One is that there will be cloud native platforms. It will be cloud first solutions. So everything will be on the cloud, and it will be multi-cloud. So they're not just moving one thing to one cloud, one region. They're moving to different regions, different clouds. It might be because they're cherry picking costs of different clouds. Cold data storage might be cheaper on one cloud than an AI solution on another cloud, or they might acquire enterprises that were using different clouds and then need to integrate these clouds. So they're moving to the cloud first, and they're moving to multi-cloud. The edge computing that they're using, whether it's mobile edge computing or fixed edge computing, will generate a lot of data. It will not just consume, it will generate a lot of data as well. And this data needs to move from these edge locations to other edge locations or to central locations in the cloud. The IoT devices that will power the mobile edge computing will keep growing. It's been growing already, but we are really only at the very beginning of what is called the Industry 4.0. So there's going to be an exponential growth of IoT devices and IoT use cases. With this complexity of IoT devices, use cases, clouds, et cetera, and the lack of skills, enterprises don't have the budget to hire everybody they want, but even if they did, there's just simply not enough skills available in the market. So enterprises, to manage this complexity, need to automate every single piece in the process they have, try to remove any manual work effort, and try to digitalize that piece. So they need to be able to consume services that can be automated. And lastly, with all this data moving from devices to devices, borders, across networks, across borders, enterprises need to manage the digital data sovereignty. It will be a critical aspect of what they have to do, demonstrate to their regulators, to their governments, and to their own customers. So what's today's limitation in that context of enterprises using data and mobile connectivity? So the existing IoT and fixed wireless access, they're limited in a sense that the services that are offered in the industry by mobile operators or IoT MVNOs, they take data from the edge device and they dump it at the P gateway or UPF or 5G. They dump it into a border router that then goes on the internet, and the enterprises are left having data at a border router and having to do IPsec tunnels over the internet to take this data all the way to the clouds, because it is where the data is going to be consumed and used. So the use of the internet for this piece of the connectivity is not ideal. Moreover, the procurement and management of these IPsec tunnels and connectivity is manual. It's manually procured, it's manually managed. It cannot be automated. And that's a problem for this need of automation of all their processes. And because there is a use of public internet, it's not secure and not entirely private either. So that's a long-term limitation for the very sensitive use cases that some enterprises have, such as finance, healthcare, and so on. So what is needed? What is needed is a true end-to-end managed solution, all the way from the SIMs that go on the devices all the way to the cloud. And that includes, obviously, the IoT and radio networks, but it also includes the IPX network if these devices are on a roaming stage. It includes the IP networks that extend the connectivity from the P gateways all the way to the public clouds. And it includes automation of all the provisioning and scalability up and down of these services. It is not just scalability up and down, it also usage-based costs. These enterprises are used to consume cloud services in a very flexible way, both on up and down CPU resources, but also usage-based costs. They need to find the same solutions on the IoT and IP connectivity all the way to the cloud. So that scalability and the usage-based cost is critical as well. The concept of this innovation is a solution that bypasses the public internet, creates layer 2 and layer 3 networks, mesh networks that enable IoT devices to get private connectivity and manage connectivity from the IoT SIM all the way to the public cloud. To take an example here on this drawing, you have cars, and these cars have several SIMs. Some of the SIMs need to provide connectivity for the car to report telemetry to a telemetry data center or cloud center of the car manufacturer. Other SIMs might be used only for software upgrades. So maybe once a month or once a quarter, they need to have a lot of download capacity to download firmware updates, which are generally pushed by edge cloud solutions around the world. And as a third use case, some of the SIMs might provide connectivity to vendors in the cars that are offering, for instance, the engine maintenance of the manufacturers, and only need to access a little bit of the telemetry or remote configuration of elements that are in the car. So all these SIMs in a car need different kinds of connectivity. All this connectivity ends up in a cloud, but it's different, needs different privacy, different bandwidth, etc. So what this solution does, it's that it configures the SIMs at the edge. It connects them to a P gateway. This P gateway is connected to an IPX network, which itself is connected to an international IP network, which itself is connected to several clouds around the world. And a software-managed single pane of glass portal or APIs enables the configuration and reconfiguration at will of this connectivity depending on the enterprise's use cases. So to summarize this, it is connectivity from the device to mobile base station, the radio network that ends up into a P gateway. This is the traditional way of selling IoT. Here, this P gateway extends over what we call Console Connect Cloud Router, which includes IPX and private connectivity, and extends these to different public clouds around the world. The different public clouds around the world is an important notion because enterprises don't just connect to one cloud in a region, they connect to different clouds in the same regions or different clouds around different regions. So this connectivity needs to span across all continents and all different kinds of clouds. Another functionality is the dynamic creation of layer 3 mesh networks. So these IoT devices need to talk to themselves, need to talk to some data centers, not others, some clouds, not others. So this configuration of layer 3 connectivity needs to be flexible. It needs to be automated as well to reduce the pain and complexity and resources needed for the management of this connectivity. It needs to have good SLA, but especially routing and latency predictability. So the software developers in the enterprises that are going to use use this connectivity to the cloud need to know for sure what is the latency they can expect, not just on the radio signal, not just up to the P gateway, but all the way to the cloud, and not depending on the good health of the internet at that point, since this does not use the internet at all. The routing, the predictable routing, will also enable them to ensure data sovereignty, because they will be able to control which data is going through a country, a region, and can they go through that country or that region, which is not something you can control if you use the internet. So the benefits, it's providing end-to-end connectivity with managed security, managed privacy, managed quality. It's to automate the provisioning and reprovisioning at will of this connectivity to the enterprises based on their use cases. But it's also scalability. Again, they expect to have the same kind of scalability that enterprises have when they buy cloud services themselves. So the scalability of the solution that we're proposing today goes from 10 meg all the way to 100 gigs. It can be procured for 1 day up to 3 years. So if somebody has to do a software update the last day of the month every month, and they need a huge capacity, but just for 24 hours, they can easily configure that and scale not only the cloud resources to provide this CPU for once a month, but also can have the same connectivity for once a month. The IPX diameter signaling and network analytics are all included. It's again from the SIM all the way to the cloud, and including the roaming network if the SIMs are roaming. It's available as a self-service, but also through APIs if the enterprise choose to include the provisioning of this capacity directly in the code of their own software and own use cases. We offer this solution by offering our own SIMs and the configuration and provisioning of our own SIMs all the way to the cloud. But we also offer the solution where we only provide the connectivity from the P gateway all the way to the clouds and connect to partners that have their own SIMs, have their own radio network already. They don't need to buy ours, but what they need is to plug their network into our IP network and offer this orchestrated connectivity all the way to the cloud. So those are the solutions and benefits of the innovation. We have two models to facilitate the go-to-market. In the first model, the enterprises buy IoT SIMs to an IoT partner. This IoT partner procures the connectivity through APIs or portals and manage this connectivity for their own enterprise. So the enterprise only has a single point of contact, which is the IoT partner, and gets connectivity and SIMs end-to-end. The second model is where the IoT partner keeps selling the IoT SIMs and managing the IoT part of the service, but the enterprises access directly into Console Connect to manage and recompose their layer 2, layer 3 connectivity to choose which SIMs get access to what. So I talked earlier about another solution like travel SIMs, which is very popular now, but it's using price arbitrage, and the window will not last 10, 20 years. Here, we're relying on the evolution of Industry 4.0, which means that the revenue is going to keep ever growing as the use case and the deployment of these Industry 4.0 use cases keep growing. So what is required to deliver a service like this? Well, let's take it from the ground up, or should I say the water up. You first need a network, and Console Connect has been having a network for the last 20 years serving enterprises. We have a terrestrial and submarine capacity in all continents, an IP network that spans across all continents, an IPX network that spans on all continents as well, and now a software orchestration that manage all these pieces of equipment and make the connectivity available as a service, so network as a service, all fully owned and managed by Console Connect. IPX Connect is a concept that's part of this innovation that enables the different parties to get different connectivity. So best is to give you an example. If an enterprise that has 3 manufacturers in 3 different locations, they have 1,000 IoT SIMs and devices across the 3 different locations, they need to choose which device can talk to which other devices, which central locations, which cloud databases, etc. So there's different layer 3 private networks that can be configured between these 1,000 devices. But this enterprise itself might have vendors. Maybe they use IBM Analytics. Maybe they use ChatGPT AI for some functionality. So all these vendors, that the third-party vendors that the enterprise has, need to also gain connectivity in a very secure and controlled way to these devices. So what the solution offers is the composability of all these private networks, where you can add on which devices are part of the network at any given time, which third parties have access to the network at any given time, which elements in the cloud and where in the cloud these CPUs have access to the network at any given time. You can manage privacy, QoS, but also ensure that your digital data sovereignty, you know exactly what's happening with your data, your devices, your network, and the services for your customers. So all this is composable at will, including the IoT devices and their SIMs. So the technology that's used, it's again all the MPLS and enterprise knowledge that Console Connect has been doing for many years, but essentially a software-defined platform that's been developed over the last few years. It amounts to millions of lines of code and enables us to be the first and only software-defined network that combines an end-to-end orchestration through APIs with our own private IP worldwide network available in all clouds in all continents, or IPX roaming network and mobile connectivity when we are the ones providing our own SIMs. But if we use the SIMs of a partner, then the partner is providing his own SIMs. The proof of concept is very recent. It was launched on production in December 12. And we have recently opened the possibility of using the service, not just when we sell our own SIMs, but we are able now to plug into MVNO that have their own SIMs, their own radio network, but plug their P gateway into this solution and are able, with their own SIMs and our IP connectivity, to offer a full end-to-end orchestrated service to their enterprises. So the way to manage the service is digital. So you have a platform where you control all the connectivity, whether it's the IoT devices, the mesh networks, the connectivity to the cloud, all the way to the CPU within these clouds. So customers can choose to manage that through a platform or to use APIs to build these metrics, monitoring, provisioning, downgrading, etc. All that directly into their own code of their own software and own use case. What's the future and where we stand? So we did a soft launch in February last year. We fully launched in December. And the next frontier for us is slices of 5G. So right now, we're able to create different IP VPNs in a managed private IP network, providing connectivity to different clouds and different data centers and recompose these private networks at will. We are also able to configure IoT SIMs, attach the IoT SIMs to the different networks, increase the capacity of the IoT SIMs, and provide connectivity at will from the device to the clouds. What we cannot do is to change the QoS experienced by these SIMs in the radio network, the so-called 5G SA slices. So we're working with partners to orchestrate those slices, which will then bring us a full end-to-end from device to cloud management of the QoS experience in that path, including the slices on the radio network. So very excited about that. And that will open up, again, another step into Industry 4.0 move and evolution and revenues, long-term revenues for mobile operators. So to conclude, it is a solution that goes from the edge SIM all the way to the clouds, providing a managed connectivity, enable enterprises to move their use cases from their edge devices to the cloud. And again, this is the part that is really important. It's not enough for MNOs to provide connectivity from devices to a P gateway. Enterprises want full control from the edge location where they are, all the way to the destination cloud or data center where this connectivity is. And MNOs need to embark and provide the solution to these enterprises if they want enterprises to be a main source of monetization of the 5G investments and the long monetization of Industry 4.0 for the next 10, 20, 30 years to come. Thank you very much.